Hello students. So today we are going to continue with one example. Okay. So the example is you have to find the coordinates of the foot of the perpendicular drawn from the origin to the plane. So coordinates we have to find. So there is one plane, okay, in 3D. And there is a line passing through this plane, okay. And you have to find, this is from origin, right? So you have to find this point, that is foot of the perpendicular to that plane. So let this point be x1, y1, z1, okay. And equation of the plane is given 2x minus 3y plus 4z minus 6 equal to 0. Okay, now first you have to write this equation of the plane in normal form, that is with distance and all. Okay, so first you find out the direction cosines. So in the previous question the same equation of the plane was given, so I'll directly write the normal form of this. Okay, 6 upon root 20. So this is the equation of the plane. Now we have taken point x1, y1, z1 as foot of the perpendicular. Okay, so now this x1, y1, z1 are the direction ratios of OP. Okay, OP line. So x1, y1, z1 are the direction ratios, and since this is the equation of the plane, we can take this 2 upon root 29, 3 upon root 29 and 4 upon root 29 as the direction cosines of this line OP. Okay. Now we know one relation, that is this L is the direction cosine, right? L, M and N. So L we can write as direction ratio, okay, one, that is A, B, C are the direction ratios, suppose. Then we can write L A upon magnitude of that vector, right? So this way we can write M also, N also. Okay, so if we take this L this side, okay, A upon L, B upon M and C upon N, then this is equal to some constant, right? So direction ratio upon direction cosine, that is they are proportional and it is equal to some constant. So this condition we are going to use here. So this is 2 upon 2, sorry, x1 y1, x1 upon 2 upon root 29, y1 upon minus 3 upon root 29, z1 upon 4 upon root 29 equal to some k. Okay, so now you have to write this x1 in terms of k, that is x1 equal to k times 2 upon root 29. So your x1 is 2k upon root 29. Then y1 is minus 3 upon 3k upon root 29 and z1 is 4k upon root 29. Okay. Now you have to substitute this x1, y1, z1 in this equation, that is equation of the plane. Okay, so that you will get the value of k. We can substitute in this equation because it is on the line OP, that line OP is on that plane, so we can substitute this points over there. So substituting in equation 1, you will get 2 upon root 29 into x1, 2k upon root 29 minus 3 upon root 29 into minus 3k upon root 29 plus 4 upon root 29 into 4 upon 4k upon root 29 equal to 6 upon root 29. So this will be 4 upon root 29, 4 upon 29 minus plus 9k and 4 4 the 16k upon 29 equal to 6 upon root 29. So you can take this, this will be 13 plus 16, so it is again 29. So 29k upon 29, so you will get k equal to 6 upon root 29. So your k value is 6 upon root 29. Okay, which you can substitute here, okay, in x1, y1 and z1, and you will get x1, y1 and z1 value. Okay, so I'll just write it here. Our k is 6 upon root 29. So x1 becomes 2 upon root 29 into 6 upon root 29. So this is 12 upon 29. Okay, like that you will get y1. y1 it will be minus 3 into 6, so minus 18 upon 29, and z1 you will get 4 into 6, 24 upon 29. Okay, so this is the foot of the perpendicular. Next subtopic is equation of a plane perpendicular to a given vector and passing through a given point. So there is a plane which is perpendicular to a given vector and second condition is it is passing through a given point. Okay, so suppose it is like this. There is a plane, okay, and we have vector A and position vector R, okay, and there is a normal vector N which is perpendicular to this plane. Okay, so plane is passing through a point A. This point it is passing and it is perpendicular to a vector N. R is any position vector, okay, with point xyz. Then the vector form of this type of, for this type of condition is R minus A vector dot with n vector to 0. This is the vector equation of the plane. Okay. In Cartesian form it is given by A x minus x1 plus b y minus y1 plus c z minus z1 is equal to 0. Okay, where A point is x1, y1, z1, okay, and P point is x, y, z. Okay, this is a vector A and this is that position vector R. Okay, and your n vector, okay, normal vector which is perpendicular vector, okay, it is given by AI bj plus ck. Okay, this you have to remember. Means you should know which are the scalar components of which vector. Okay, so for A it is x1, y1, z1, that is your vector A. Okay, through that point the plane is passing. Then P vector xyz, that P point, which is for position vector r xyz, and N, that is a perpendicular normal vector, for that it is ABC. Okay, let's solve one example. Find the vector and Cartesian equations of the plane which pass through the point phi 2 minus 4 and perpendicular to the line with direction ratios 2, 3, minus 1. So here this plane is passing through a point. So point is your A point, right? So this is 5, 2, minus 4. So your A vector becomes 5i plus 2j minus 4k. Okay, and it is given that it is perpendicular to the line with direction ratios. So perpendicular means this becomes your N vector. Okay, so direction ratios are given, so you can directly write the vector form, that is 2i plus 3j minus k. Now find out the vector equation. Okay, vector form. So it is given by r minus a dot with n. So r vector is our xyz, right? So x minus 5 I plus y minus 2 j plus z minus plus 4 k. Okay, dot with this 2i plus 3j minus k equal to 0. This is vector form. Then Cartesian form. Now I'll write first x minus x1 plus b y minus y1 plus c z minus z1 equal to 0. So a, b, c are n vector. So 2, 3 and minus 1. So 2 x minus x1 is 5 plus 3 y minus 2 plus, this is your minus 1, z minus z1 is 4, so 4. So this is Cartesian form. So further you can reduce this. So this becomes 2x plus 3y minus z, then numbers are there, minus 10, minus 6, minus 4. So this will be minus 10, so minus 20, correct? So you can write equal to 20. So this becomes your Cartesian form. Okay. Next subtopic is equation of a plane passing through 3 non-collinear points. So here 3 non-collinear points are there. Three non-collinear points. So collinear and non-collinear. Collinear means the points are in a straight line. Non-collinear is points are not in a straight line. So they will be in different planes also, maybe. Okay. So this is the plane given. Okay. And the 3 points are there, say R, S and T. Okay, which are not collinear. So okay, and there is one more line, okay, one more point, which is point P. This is R, S and T, which is a position vector R. Okay, so for point R I am giving A vector, for S I am giving B vector, and for T I am giving C vector. Okay, and this is perpendicular. So the equation vector form is given by R minus A cross with B minus A cross C minus A equal to 0. RS cross RT is perpendicular to the plane. Then there is a collinear form. Okay. Sorry, not collinear, Cartesian form. So for Cartesian form, the points you have to take x1, y1, z1, then x2, y2, z2, and x3, y3, zt. Okay, R, S, T. And position vector, which is R. So for that, P point is x, y, z. Okay, then the Cartesian form is given by a determinant x minus x1, x2 minus x1, x3 minus x1. So y minus y1, y2 minus y1, y3 minus y1, z minus z1, z2 minus z1, z3 minus z1 equal to 0. Okay, let's solve one question. Find the vector equation of the plane passing through the points. So your points are given R 2, 5, minus 3, S minus 2, minus 3, 5, and T 5, 3, minus 3. Okay, so vector form. So R minus A dot in the formula I have given cross. I think it is not cross. Here you have to take dot, and inside the bracket you have to take cross. Okay, please note that. So this is P minus A cross and C minus A equal to 0. So you have to just write the vectors. Okay, R minus A vector is this. So 2I plus 5j minus 3k dot B minus A. So this is B and this is A and this is C. So B minus A, minus 2 minus 2 minus 4I minus 3 minus 5 minus 8j, 5 plus 3 8k cross C minus A. 5 minus 2 3I, 3 minus 5 minus 2j minus 3 plus 3 0. So this is the vector form of the equation. Okay, next is intercept form of the equation of a plane. So intercept, what do you mean by a intercept form? So intercept means whenever any line touches the axis, okay, if this is the line and it is touching the axis, x-axis, then this point becomes your x-intercept. This points, if this is y-axis, this point becomes your y-intercept. Okay, so if there is a plane which is touching the all three axes like this, okay, R, P, Q, suppose this is a comma 0 comma 0 x-axis, for this it is y-axis 0 comma b comma 0, and this is z-axis 0 comma 0 comma c. Okay, then the intercept form is given by x upon a plus y upon b and z upon c equal to 1, where a, b and c are the intercepts. Okay, now suppose there is an equation with you have to find the equation. Okay, suppose question I will take, find the equation of the plane with intercepts 2, 3 and 4 on the x, y, z axis respectively. So here directly the intercepts are given 2, 3 and 4. So directly you can write x upon 2, y upon 3 and z upon 4 equal to 1. And now you can write this is plus, sorry, in the form of a equation of a plane. So can make the denominators equal. So this will be 6, 3 4s are 4 3s are, right? So you'll get 6x plus 4y plus 3z equal to 12. So this becomes your equation of the plane. Okay.